So we'll start today with machine learning. Okay. So today I'm not sure how much we can do on the practical stuff, but let's see. First, let's understand what it is, right? And what we do in machine learning, why it is used. So the reason the name suggests, right? Machine learning, right? So what are we doing here in the session, in the class? We do what is called human learning, right? So, I'm your instructor and I'm going to tell you something new, right? Something new that you probably didn't know, right? So that's called human learning because you want to learn something and I'm here as an instructor to tell you about that, right? So same thing what we are doing in machine learning is we want machine to learn, right? We want machine to, we need to train machine, okay? Just like we, train human being, okay? Because we learn something new because we want to do something new, isn't it? Okay. So if you want to work with machine learning, for example, you need to know what machine learning is, isn't it? So similarly, we want machine to work for us. So we need to do what is called machine learning. So machine learning algorithms are standard. So what does algorithm mean? Algorithm means standard process, standard steps. Okay. So when it says algorithm, it means that it has a standard step of taking input, processing it, and giving output, right? So we are going to learn, okay, different machine learning algorithm using which we can train machine learning. And why do you want to train? Of course, machine has its own advantage, right? Machine can process a lot more data than what we do. It can work 24/7. We can't work 24/7, isn't it? So, so because of those advantages, what we want machine to learn like how we think, okay, and so machine, think like me and then do my job, right? So okay, that's the end objective of doing machine learning. So okay, so till now, okay, the kind of programs we're doing are not called machine learning programs. Okay, so there is a definition. Okay, so just read this definition. It says a computer program is said to learn from experience E with respect to some task T, okay, and some performance P. Its performance on T as measured by P improves with E. Okay, so coming about human learning. Okay, when we say human learning, it means what today. Okay, if I measure your performance on some task, I give you some task and I measure your performance. Okay, so let's say if the performance is P, after the class, after you learn something new, your performance on the same task, right? So T is same. We're not changing T. What we're changing is E, experience. We're changing the knowledge. So I'm going to give you more knowledge and then measure you on the same task, right? So performance has to improve, isn't it? So let's say your the assignment marks that you will get at beginning of the year, okay, and on the same questions comes at end of your year, you will be performing better at end of the year because you have learned something new in your course, and now you're able to perform better on the same task, right? That's what we say, right? If I ask you something today, okay, so why do we trust experienced people? Because they probably have more experience and then they can do things better, right? Okay, if I give a mathematics problem, Gauri probably will do better than Keshav, isn't it? Because Gauri has got more experience, got more knowledge on mathematics, right? So that's called learning because we are learning. So now if Gauri and I do same problem and if Gauri is able to do better than me, that means I have not learned, right? Okay. Similarly, when you talk about computer program and the programs that we have done so far, okay, for example, let's say calculation of an average, right? Now, when you do average today and same program you run after 50 years also, it's going to give same output. It's not going to improve. It's not going to give better result. So that those are not called computer. Those are not called machine learning programs. Machine learning programs has to give you better result. So when I say better result, now you know that the result that you will sometimes the result would change. You won't get same result every time. So how is that possible? Okay, it's possible because of what we call as data. Okay, and it uses probability in the back end. Okay, so so the way. Okay, so let me. Okay, think of the existing programs that we have done as set of process and input. Okay, so example, if you have to do average itself, so we give numbers as input, and the process is that you add them and you divide them by total numbers, right? I mean n. Then you get an average value. So we are giving input. We are telling program follow this process. Okay, we're giving input and we're giving the process as well. Follow this process, and then computer gives output. Now, if the process, okay, remains same, your output will also remain same, isn't it? But in machine learning programs, we don't give process. Okay, we don't tell how to do it. We give input and output, and we say machine, okay, this is the input, this is output. I want you to think the connection between input and output. Okay, think the connection between input and output, and you give me okay, so you don't ask for the process. Okay, this is the input, this is the output. You think about it. Okay, and now I'm giving you new input, give me the output. So you are not telling, okay, program what to do. Okay, so let me give you an example. Okay, if you are still not able to get it, okay, let's say, okay, I say 2, comma, 4, comma, 6, comma, dash. Okay, so this is the input and output. Okay, 2 is input, 4 is output. 4 is input, 6 is output. 6 is input, dash is output. What will I get here? What will
8.
8, right? So did I tell you what to do?
No.
No, right? So I gave you input, I gave you output. You thought about how, what is the link between input and output? If I give 2, output is 4. If I give 4, output is 6. So what is the link between that, right? So you understood the link, okay, and then you used that same logic what you came in your mind, okay, and you gave me A, okay. It was possible for you to give me some other answer as well, right? Let's say if you got it wrong, let's say, okay, let's say if you get the connection wrong, you might give me some different output. So same thing, okay. So this is how machine learning program works. We give input and output. Machine learning will look at the input and output, and it will do the processing in its brain and then gives you the output. Okay, if you train your machine learning well, just like if you're trained well enough, you will be able to answer this. Maybe a 4-year-old, 3-year-old may not able to give this answer, right? Because they are not well trained. So when we say experience means more data you capture, right? If you don't go to school, if you don't study, it doesn't mean whether you are 5-year-old or 50-year-old, right? But as you learn things, okay. Now learning things can be two ways. One way is there's an instructor who tells you, okay, this is odd number, this is even number, right? And there are other ways where you learn by yourself, right? You look at maybe you watch a movie and you learn something from movie. Possible. You watch your parents and you learn something from them. Possible. So nobody told you do this, do that, right? But you know what we should do, like and what you should not do, right? By looking at the people around you, the situation. So in machine learning, when there is an instructor, when they tell you, okay, this is input, this is output, okay, understand from here, we call it as supervised learning. So in supervised learning, you have input and output data, okay, output data to know what it is, okay, And okay, this is called supervised learning. In unsupervised learning, okay, you don't have output data. Okay, it is possible. Okay, so for example, I think I have some examples here. So at least now you know what machine learning programs are. Okay, machine learning programs are the programs, okay, which uses data to predict the outcome. So it's going to predict what will be. Okay, you remember that example 2468, right? So the way you will, okay, nobody will tell you what you need to do. Okay, so now for example, when you are driving, okay, I don't know, I mean, if you are eligible to drive or not, but let's say when you're driving, okay, you go to driving school, right? And in driving school, they will tell you a few things. But when you're actually on the road, okay, you will have to make more decisions than what you were told in the driving school, isn't it? Maybe a 90% decisions you have to make on your own there, right? So based on that knowledge, you're implementing the driving thing. Driving output is the final output is your driving. Okay. So did you get to some extent what I'm trying to do here in machine learning?
Yeah.
Okay. Based on the input and output, I'm trying to understand the pattern, and then based on that pattern, I'm going to predict. Okay. So as a data, we only provide input and output to the program. Okay. So when we have input and output, we call it a supervised learning. Because output is given, you know this, okay, this is the input, this is the output. For new set of input, what will be the output, right? In supervised learning, you will not have the output, okay? So how does it, and so there are two types of learning I told you, supervised, unsupervised, and third was called reinforcement learning, okay? So let's look at this example. This example we'll spend some time on it, okay? And if you understand this diagram, 50% of machine learning is understood. This diagram is important, okay, from my perspective, okay. So machine learning, if you see, there are four types, okay, mainly three types, but we call four types. First is supervised learning. So in supervised learning, you have the input output. You're trying to predict the outcome of new input. Then you have unsupervised learning, where you don't know the connection, okay, but still you're able to find the output. It is possible, okay. Semi-supervised is mix of supervised and unsupervised, okay. So sometimes you will use supervised and unsupervised, sometimes unsupervised and supervised, okay. So mix. We'll take examples and also we'll understand. And the last one, okay, is called reinforcement learning. So I said, right, when you learn in a classroom, it's like supervised learning. When you understand, or when you learn from your environment, when watching someone, okay, watching something, okay, okay. So it's called unsupervised learning. There's nobody tell you do this, do that, but oh, this is what we should do, or this is not, we shouldn't do that, right? And the last one is reinforcement learning. Okay, reinforcement learning is you do something and you get a negative thing, right? Okay, your mother scolds you, then I shouldn't do it. So that's a feedback based. Reinforcement learning is feedback based learning. Okay, where initially you don't know what to do, you do something and you get a negative feedback. Okay, or you get a positive feedback. So when you get a positive feedback, it means that you should do it more, right? You do something and your teacher says good, your parents says good, then oh, I need to do it more. I need to do it more often. And when they scold you, they give you less marks. They scold you, they tell you no, then you know that, oh, I shouldn't be doing that. Okay, it's called reinforcement learning. So same thing in our machine learning algorithm framework. Also, we have this kind of learning. Okay, we'll take example and we'll see how actually these are implemented. So okay, so these are four types of learning, mainly three types, right? The third one, what you see, is a mix of one and two. The next thing that we need to know is, okay, what type of output variable is. So when you say this continuous and categorical, they're called as target variable. Okay, target variable is nothing but the output that you want. Okay, if the output is continuous variable, So I think everybody, you both know what is continuous and categorical. Categorical is group, right? Good, bad, good, bad, poor, right? It could be excellent, very good, poor, right? It could be male, female, yes, no, right? So it could be ordinal or cardinal, right? Where the order is important, where order is not important. But you have group of values, you have limited set of values. From that only the output will be there. Okay, you want to know whether your customer will buy your product or not, yes or no, right? You want to know whether it's going to be a male or female. Let's say you want to you have something based on gender, and you want to know whether it's going to be gender, right? Okay, sometimes you want to know whether this is going to give me excellent feedback or poor feedback. So these are called categorical values. So if the outcome, if what you want is categorical, you will be implementing classification algorithm. So what you see here in orange box, they are algorithms. Okay, it's a family of algorithms. So classification will have 100 algorithms. Regression will have 100 algorithms. So what you need to do is, before you start working on machine learning algorithm, is you need to first understand what is it, is it supervised, unsupervised, semi-supervised, or reinforcement. You have to think from that perspective first. Okay, based on the question, okay, you will know that okay, this is supervised or this is unsupervised. As you practice more and more, you will realize. So that is first thing that you need to know. Second thing that you need to know is the output. Why? Okay, we call it Y target, output. Okay. What is the output variable that you want to find? Okay, if output variable is is a categorical variable and the learning is supervised, then you will be using classification algorithm. If the output is continuous value, then and supervised, then it is a regression family of algorithm. Okay, so regression is not just one algorithm, there are many algorithms. Okay, so what we need to understand is, we'll understand what these are, and then we'll take one example of each, okay, to understand how it is implemented, right? Okay, example, let's look at the example. Housing price prediction. Okay, let's say you have money and you want to invest in some property, right? So when we invest something, right, we want to, so you would first predict, right, what could be the price of this house. If I'm paying today X amount, okay, what will be the price of this house after a year or after 5 years, 10 years, right? And that's when you invest, right? So housing price prediction. Okay, of course, today's price, okay, we want to predict what will be the price after 1 year or after 5 years. Okay, so now to predict housing price after 5 years, you need to know what is the price today, isn't it? So we need to know the current input and output. Okay, today's price is X dollar. Then okay, now it's going to be X plus or X minus, how much, okay, more than X. So this is an example of supervised learning. Because if you don't know today's price of the house, you can't predict the price after a year, right? So you need to have the data, okay, today's data. So that's why it's an example of supervised learning. And the price can be anything, right? Dollar can be anything. It's not a group. It's not like you're selecting high, low, medium. Okay, it's going to increase by high or decrease, increase or decrease. Now, if you talk about increase or decrease, okay, just two values, it becomes categorical. Okay, the classification you have to use. But you are trying to predict the actual dollar value. Okay, so you will use regression. That's continuous out target variable. So, generally when we write a mathematical equation, we say y equal to some x, some x1, some x2, x3, right? So your y is one variable. Y is fixed. It has to be one output only, right? That is the price of the house. Now it can depend on multiple factors: distance from the nearest supermarket, distance from the airport, distance from the corporate office, distance from the city center. All these factors will impact the price, isn't it? Those are called as X. or features. We call them as features. Features can be multiple features. It can be 1 or 50 or 100, doesn't matter, but only one continuous variable you can predict. Okay, and here that is the housing price. Okay, so we are trying to predict the housing price. Okay, and we have some features. Based on that, we will be predicting what will be the price. Today we know, okay, today's distance we know, okay, today's all the features, right? This distance from airport, distance from hospital, distance from school, whatever, right? All those factors which actually either it should positively impact or negatively impact. Okay, the distance from airport is near. So okay, so because of which in his, when you look at the pattern, current data, you know, okay, that will impact by 3%, or price will increase by 3%. Okay, distance from city central, okay, oh, it's far off, oh, it's going to decrease the price by 2%, right? So each of those factors will play either increase or decrease. If they don't play any role, if they don't impact, let's say distance from school doesn't impact the housing price, okay, maybe distance from the best school, right? Okay, but let's say in that area there is all the schools are of, let's say, you know, in same kind of school, right? Then the distance from school may not be a factor which will impact either positively or negatively. Then we take it out. When we do examples, we'll do that. Then you remove that, okay, because it's not having any impact, we'll remove it. But if it is having impact, positive or negative both, okay, then we will include it. Yes, did you understand this chain? What is regression algorithm? What is regression algorithm? So regression algorithm is supervised learning where we predict continuous target variable. Yes?
Yeah.
Is it too much for you, Keshav?
No, it's fine.
Great. Okay. So then we talk about classification. Classification example is medical imaging. Okay. Now, when you say medical imaging, okay, I can take any one example, X-ray. Okay. When doctors look at X-ray, right, they classify it as like, you know, there seems to be a problem or no problem, isn't it? So here the outcome is problem or no problem. Right? Somebody goes with broken limbs, and when you look at the X-rays, you know, you're fine. Okay, there's, you know, it's not broken, and probably take tablet, you'll be all right in a week. Oh, there is a problem, we need to do, you know, surgery, or we need to do plaster or whatever, right? So when you look at an imaging, okay, here the doctors are trained. Okay, even if you don't have a doctor, even if you talk about machine, if they're trained to know, okay, that if image has something like this, it is problem. If image is something like that, there's no problem, right? So that knowledge is predefined. Somebody has taught you, so you have to, you know, as a doctor, you know, somebody has taught you in the medical school. They teach you, right? When you see something like this, that means your X-ray is fine. If you see something like that, that, you know, that means your X-ray is not fine, and you need to, you know, do something, right? So that is called supervised learning. Okay, when machine, when if you want to pass a X-ray film through, say, algorithm had would have been trained, right? So if you see, okay, if distance between two dark images is more than 5 mm, there is a problem. The difference, the two dark images are, or whatever. I'm just giving some random example. So you have to train your model beforehand how to classify as problem image or non-problem image. So outcome here has 2 variable or 3 variable or 4 variable. You can have 10 variable, but it is fixed. Okay, even if you have 10 variable, it has to be answered one of those 10, right? It cannot be anything, just like, you know, housing price. Price can be anything, right? It can be $5,000, it can be $5,001, $5,001.5, also 50 cents, right? It can be anything. But in classification, no. You know, you have a group of values, and you are predicting just one of those values. So medical imaging is an example of classification. When you have to do that, you have to do classification, because one thing is reading and second thing is classifying that as problem or no problem, right? Okay, so that's an example of classification. So Mostly, okay, most of the 50 to 60% of the work that you do will come from supervised learning, okay. But so unsupervised learning is also important. In unsupervised learning, okay, target variable is not defined, is not available because we don't know, okay. So we use two types of algorithm here. One is called clustering and association. So clustering is like grouping, okay. Um, uh, so I'll just talk about customer segmentation, okay. Let's say when you log on to Amazon.com, right, and when you try to buy any product, Amazon will have a lot of options down there. Customer like you has bought, there's a thing, right? Customer like you bought this, or you may be interested to buy this. How does Amazon know that you will be interested to buy? Well, it's right or wrong, that's a different thing. Okay. But how will Amazon know what you want to buy? It's going to predict, right? So what it does is it will have millions of customers, isn't it? Based on your nature, okay, based on your buying pattern, kind of products you buy, kind of amount you spend, these are the features, okay. It will take those features and it will create a group. So there's no outcome, there's no output variable here. So it is only the input data, and based on input, it is going to, okay, it is going to create groups, okay. So let's say you have, 1,000 customers, it will create probably 10 or 100 groups, right? And okay, in each group, let's say, you have 50 people in each group. So let's say if all three of us fall in same group based on our buying pattern, if I buy something, okay, you will see that people like you has also bought this. So assumption is once you form the group, right? Let's say, uh, in your college, right? In your college, when you look at your other students, let's say some may be great at studies, some may be great at sports, right? So when you classify, oh, these people are great in studies, these people are great in, or they do too well with sports. So when there's a sports competition, you expect that group to perform well, okay, that specific group to perform well, because in your mind you have done the clustering, okay, out of maybe 50 people, okay, you're saying, okay, these five will do well if there is a chess competition, okay, if there is a sports competition, these five people will do better. How? Because, based on their pattern behavior, you assume that these people are good at something, right? So same thing here, based on the features, okay, we are trying to identify and say, okay, this is a group, okay, they behave similar in nature. So if anybody does something in that group, Amazon will use that knowledge to show that, show that, like if I buy something, it will use that knowledge to show you that you might be interested in buying this, because we are in the same group. So most likely we will have same behavior, and that's why we are in the same group, right? Okay. So in such cases, we use clustering algorithm, clustering family of algorithm. Okay. Regression, classification, clustering. I'll give you one example here. Okay. Let's say I have a room filled with fruits. Okay. At the center, okay, I put apple, banana, cherry, and let's say mango. I have dumped the fruits, okay, and I have kept, four baskets at the four corners of the room. Okay, so I've labeled basket as apple, banana, cherry, and mango. I'll tell you, okay, segregate, okay, or from the dump, put all the apples in the apple basket, bananas in the banana basket, cherry in the cherry basket, and mango in the mango basket. Can you do it or not? You guys listening?
Yeah.
So can you do that? If I tell you, put all the bananas in banana basket, cherry in cherry basket, apple in apple basket, mangoes in mangoes basket. Can you do that? Yes or no? What happened?
Yeah, I mean, if the number of fruits is less, then we can do it.
Why? It'll take more time. So what? if fruits are more, it might take 1 week to do it, but still you can do it, isn't it?
Yeah.
Right? So you can do it, okay? And that's an example of classification where you know these are fruits, these are apple, okay, and you have an apple basket, you go and put it in apple basket. Now let's say, and apple, banana, cherry because you've been taught in your class, right? When I say apple, a picture of apple comes to your mind, isn't it? When I say banana, a picture of banana comes to your mind because you've been trained. Now let's say, for example, I get some exotic fruits, okay, from some island, and those fruits you have never seen them before. You don't know the names of those fruit, okay. So I put those four fruits in the room, and I put 4 baskets, and I tell you, put same fruit in each basket, okay. Since I don't know the name, you don't know the name, I have not labeled it, okay, but I wanted to put them in same basket. Can you do that or not?
Wait, can you repeat that?
Okay, so I'm saying same experiment, okay, but the names of the fruit we don't know, okay. Or for example, let's say that you have never seen apple, banana, cherry, and mango. You don't know what are apple, banana, cherry, and mangoes. I put those fruits in the room, and I put 4 baskets, and I want all apples to be in one basket, all bananas to be in bananas basket. Does that we don't know the names of the fruit? You do it or not?
Wait, do we know what those fruits are?
No, we don't know the names.
Then we can't do it.
You can do it, isn't it? Because each
No.
fruits, they'll have its own color, size, shape, right? So when you hold a fruit, even if you don't know the name, if I give you bananas and apple, and if you don't know the names, still you can segregate bananas and apples, isn't it?
Oh, I thought you meant we don't know we don't know that an apple is an apple. Like we don't know the fruit.
You don't know the apple, right? You don't know the name, right? But you have the characteristics, okay? For a moment, forget that you know apple and banana. Okay, for a moment, you forget that you know those fruits. But if I dump apple and banana in front of you, will you not be able to segregate them into 2 groups?
We can.
You can, right? That's what I'm trying to say. Even though we don't know the names, still you can put them in groups. Just that you don't know the names of those groups, right? You don't know it whether it's apple or banana. Okay, but still you will be able to put them separately or put all similar fruits together. So that's where it's called unsupervised learning, where you don't know the names. Okay, so when you segregate the customers, you don't know what's the name of those customers, and you don't need it. See, if I'm telling you put the fruit separately, you don't need to know the names. Okay, if I ask you what's your favorite fruit, in that case you need to know the names. Okay, but if you just have to put them together, you don't need to know the names. Okay, so that's an example of unsupervised learning. Okay, so you don't have to know the names, because as long as if you're asking me to, okay, you want me to put them separately, I don't need to know their names. But if I tell you which is the most sweetest fruit, tell me from the group, then you should, okay, tell me, I like this one, what do we call this? So I say, oh, this is called apple. Then you say, okay, I like apple more, right? So that's an example of classification versus clustering. In clustering, you're only creating a group, multiple groups based on shape, size, characteristics, right? So buying pattern is an example of characteristics, right? Amazon grouping us, okay, into different groups. That's an example of clustering. Okay, so see, Walmart has so many stores, right? 4,000 or 5,000 stores across US and Canada. Now, somebody has to decide. See, the stores will not carry same product. Okay, even though there's Walmart stores, they will not have same products across different store. Why? Because it depends upon the people around that area, right? What people in that area would be interested to buy, right? So even though there are 5,000 stores, they are more specific, localized, okay? Because in that particular area, let's say mostly young people live, they cannot have something which old people like for example, dresses, right? Generally, your choice of dresses will differ based on your gender, based on your age, right? It's perfectly fine. So if there is a Walmart near university, will have similar different kind of products than a Walmart in a, say, in a small town, right? How does Walmart manage 5,000 stores? So Walmart doesn't manage individual 5,000 stores. What it does is it groups the Walmart store. Okay, Walmart near universities. So it will see how many Walmart are near universities. Out of 5,000, maybe 50 stores are near universities. So they will group it. Those 50 will be grouped as one store. Okay. Then they look at small town. Okay. So okay. So I was saying that in small town, let's say there are 100 stores in near small towns. They have similar characteristic, kind of. We call them demographics. Okay. Demographics means the type of people, their age, gender, their income. Those kind of things. Their food behavior, dressing behavior, all those things. So these 100 stores will be grouped as one. So now the store doesn't have to make 5,000 decisions. They will make maybe 500 decisions, right? So stores in one particular group, they'll make a decision. Okay, this is the kind of product I want to send. So, the decision will go to, same kind of product will go to all the 100 stores in that group. So what happens? Your decision-making capability is much easier, right? It's easy to handle 500 than to handle 5,000, right? So what they're doing, they are grouping their stores. Or we call them, store clustering. We call them as store clustering. Okay, you create the clusters of your stores, okay, based on different behavior or characteristics, right? And the decision that you make is same across all the stores. Okay? So you're doing grouping. Market basket analysis, okay, association. So here we try to figure out what is more associated, okay, or which impacts what. When you go to a store, okay, retail store, okay, they'll put, some, things next to each other. So there's a lot of brain, a lot of thinking goes into that. Okay, they look at each individual's bill and they figure out which two products are people generally buy together. So if they are buying two products together, then they will put those two products together on the shelf so that even if you forget one, let's say milk and bread. Okay, so let's say, both every people who buy milk, out of that 50% will also buy bread, for example. Okay, so so they look at all the people who are buying milk, and then so there's a separate algorithm. Okay, so we call them as support, lift, and things like that. It means simple. So let's say you have you got 100 customers for the day, and you want to see, is there any product that is associated with milk? So out of 100 product, you look at all the bills, okay, or the states where the customers have bought milk. So let's say there are 50 such stores who have bought milk. Okay, now then you look at those 50 only. Okay, and then you see out of 50, what are the other products that people are buying along with milk. So out of 50, you figure out that 40 of those have bread along with milk. Okay, then oh, that means bread and milk, they're associated, right? So you'll put milk and bread together, okay, near the shelf, so that people who comes to buy bread will also buy milk, who comes to buy milk will also buy bread. Okay, because see, ultimate goal of retail store is to increase your sale, right? You come to you want 10 things, but by the time you come out from the store, you'll have 20 things in your cart. Okay, so the store was successful enough to sell 10 more things to you. Okay, so that's what they try. They think, okay, people will come to me to buy only important stuff, 5 things, 10 things. But how do you sell more stuff? Okay, things which people generally don't buy will be more attractive. When you go, okay, the things that you buy often, like milk, okay, bread, will be kept at extreme end, and that place may not be that fancy or because they know that you will anyway buy milk. But chocolates, we don't plan to buy chocolates, but the chocolate area will be fancy, then it will look more attractive because they want you to buy those things. You don't plan to buy. So example of association is then when you put two things together, they know that okay, this product is also going to sell the other product. So in association, we try to find out which are the such combinations. Okay, so end of the algorithm will give you the combinations. Okay, milk, bread. Okay, fruits and something. So when you look at those combinations, you can use that knowledge to put your product next to each other in the store shelf, and that's the market basket analysis. Okay, that's what you do. So which two product goes well in the basket, right? In your shopping basket. So that's what we call it as association. Did you understand that?
Yeah.
Okay, so we'll not do everything. Okay, we will in the class, we will do only regression and classification. Okay, we can do clustering. Other things, okay, just to understand, okay, these are the things that are there. Okay, so let's try to finish at least the examples today. And next session, we can start doing the regression. And then third session, you can do classification. Okay, and maybe in the third one, following that, we can do clustering. One example of each of these. Then, okay, semi-supervised classification, text classification. Okay, the classic example is that, we have old records, right? People earlier, 50 years back when computer was not there, the government would maintain handwritten notes. Now you want to convert those handwritten notes into electronic format, right? So when you enter, let's say, text and it says hello, so the machine has to read HELLO and then convert that image, which is generally image that you pass, image HELLO as a text HELLO, right? Because of text classification. So okay, so when you read each character, it can be, let's say, assume that it's only text. Okay, so it can be one of the 26 alphabets only. It has to identify which 25 or 26 character it is, right? When you pass H, it should classify as H. So here it is an example of semi-supervised because first thing is you have to group all the H's together, right? And then say, okay, this group is named as H. So you're doing both the things. First group and also giving a name to the group, right? So that's an example of semi-supervised, means mix of both supervised and unsupervised algorithm. That's a classification. Okay, so classification because first you are grouping and then you are doing the naming, right? So classification does the naming. So last algorithm that you will do is classification. So we call it as classification. First clustering, then classification. Second example is lane finding on GPS data. So when you're going on the road, okay, and your GPS is able to direct, suddenly you road into two left, it gets diverted into two lanes. So okay, is it left lane or right lane? Okay, so it has to identify, right? So first it has to know. Okay, first we perform classification to know whether if lane is there or not, right? To know if there is a lane. Okay, is it single lane or double lane? Okay, one single road or double road. So first it has to know. Okay, this sign indicates there's a lane. This sign indicates there's a water. This sign indicates there's a railway track, right? So that is the example of knowing what is there. So you are classifying first, and then you are saying, okay, take this group. Okay, go on left lane, go on right lane. So second one is grouping basically. Okay, so that's what we call them clustering, and lane finding on GPS is an example of where you are performing both. Okay. And the last one, reinforcement learning, optimized marketing. Okay, now what does optimized marketing mean? Okay, so these marketing managers, right? They will give you, okay, for example, I'll give you an example. Let's say your parents says that you can watch 1 hour of TV every day or 2 hours of TV every day. Now you have only 2 hours to watch, right? And you have 100 channels to watch. Which one do you want to watch, right? So, okay, so you have to first make a decision, okay? So what you probably will do is, first 10 minutes, Okay, you will go through all your favorite channels, isn't it? Okay, and then then you say, okay, this is my favorite. Now this is my, I want out of the 10 things, okay, out of the 10 channels, you'll say, okay, this is what I want to watch for next 1 hour for 45 minutes, right? So same thing, optimized marketing is the marketing managers, okay, they'll be given a budget. Okay, we want to do promotion. Here is say $1 million. Now they will not spend whole $1 million at the same time. They'll say, okay, let let me take 100K. Okay, and there are multiple ways to do marketing, right? You can do Facebook marketing, you can do Instagram marketing, you can do Google marketing, you can put a hoarding, you can do a TV ad, radio jingle, you can do newspaper printing ads, right? So that's so many types of doing marketing. So what they'll say, okay, let's say first time they have not done anything before. So they'll say, okay, there are 10 different ways to do marketing. I have got 100K, so I will divide equally into all the 10 parts. Okay, so probably you'll have 10,000 in Facebook, 10,000 in Google, 10,000 TV ad, 10,000 paper ad, all those things will do. And then you'll measure the performance. Which one has given you more result? You figured out that Google ad has given you more result, let's say. Okay, so next time, okay, when you have to spend 100K, okay, now you will not give equal amount to everybody. Because Google has given you more result, you will give more amount. Again, you will not put all the money in Google. So let's say today you like a channel 1, doesn't mean that tomorrow also you like channel 1 only, isn't it? So tomorrow again you will give more time. Okay, but since channel 1 is, since over the period of time you realize that channel 1 has more programs of your liking. So now from next time onwards you will give more time to channel 1, isn't it? The same thing here. Second time, okay, they will say, okay, instead of doing 10K, I will give 50K to Google Ads, and rest 50K I will divide into other. Okay, then again you will measure. So it's a feedback based, right? You get a positive feedback, you will spend more money. If you get negative feedback, you are giving less money. Now, if you like the program, channel, you will give more time to that channel. If you don't like the channel, you will give less time, right? So it's a feedback based, right? That's why it's called reinforcement learning. You are doing something, you get the result, and then you are modifying based on the result. Then again, you are doing something, right? So that's why there's an example of optimized marketing is an example of reinforcement. You are learning. Okay, now we talk about driverless cars. Okay, driverless cars is also example of reinforcement learning. Okay, now it is not possible to give all the instructions, okay, when you're developing a driverless car. Okay, so there will be some, like, for example, when you're driving on the road. Okay, now when you see a vehicle in front of you, you will reduce the speed. Why will you reduce the speed? Because you know that if I don't, I will go and hit. If I don't do this, this will happen, which I don't want to happen, right? If banging cars become normal, right? If you bang car, nothing happens, banging car becomes normal, and people will not slow down, right? They'll go and just bang the car. But you know that you don't want to do it. Okay, that's a feedback. I don't want to do it, so I will not do it. I want to do it, so I will do it. Okay, you don't want to break signal, you will stop there. But if you want to break signal, you will not stop there. That's why it's called reinforcement learning. Okay, it will decide, oh, if I do this, I'm going to reach my destination faster, so you will do it. No, if I do this, I'm going to hit someone, so you will slow down, right? So we are taking decision based on what will happen, isn't it? If I don't do this, this will happen, so let me do it. If I do this, bad will happen. I don't want to happen, so I will not do it. So that's an example of reinforcement. You are giving that, okay, if I don't do this, what will happen? And then you will do that, right? Most of the time we do make the reinforcement decision, right? Okay, if I don't do this, I'm just, my mother is going to scold me, so let me do it, right? Okay, so that's the reinforcement learning. Okay, and machine also does that thing. Okay, so all those things are theory. I'm going to skip. Any question on so far what we have done?
No.
No.
At least at a high level, you understood, right, what this topic is all about.
Yeah.
Okay. Yes. And that's why, because data set is important. Data is important here because experience, right? When we say experience, what does experience mean? Experience means data. Okay. You know, you have, if I say you are more experienced, that means probably you have read 10 more books than, somebody else, right? So you have more data than somebody. More data, more easy, performance will be better. That's what we have seen, right? So our job here is to provide as much data as possible to the machine so that machine is able to make a decision, right? Okay. So before we perform this algorithm, we have to make sure that data that we are going to use is in perfect shape. Okay, it means that it is in usable format, right? So you must have heard, right? Garbage in, garbage out. What does this mean? If you do not provide good data, okay, see, it's a mathematics, okay? You add some number, you'll get some number for sure, okay? But if you don't give good data, if you give junk data, you'll get junk output, right? And then you'll say, oh, my machine algorithm is not performing well, right? You prepare for English and you go and write geography exam, right? And then you say, no, my teacher did not teach right. No, you made a mistake, right? You should have read geography for your geography exam. Right? Same thing here. So you have to make sure that data that we have is in a format which is usable, right? So the first thing that we need to do, people actually spend more time on data pre-processing. Okay, pre-processing means before you run the model, we are processing the data. Okay, but to make sure the data is in form, is in a way that can be used by the algorithm. Okay, so first thing is get data, right? So of course, I'll give you, this is the GitHub location where you can get a lot of data, data I have, you can use them, and there are multiple sources of getting data as well. Import libraries, we need to import libraries. Okay, like for example, if you want to do plotting, you ggplot2. Okay, so yeah. Okay, the first thing that we do is, today we'll just understand, okay? Next session, we'll do all these things and you'll see. First thing is called missing data. Okay, you have, uh, this example you see here. Okay, so it has 4 columns: region, salesperson, quotation, and win. So here we want to predict based on the 3 features, right? Target variable is win. Okay, and the features are your region, salesperson, quotation. So here you see the data is missing here. Okay, now how do you handle a missing data? Right, we cannot pass this data as it is. We have to manage this missing data, right? Okay, so that's what the missing data, we will learn how to handle it. Okay, so first thing is that if you have, let's say you have, in this case, let's say you have 10 columns. For example, let's say you have few here, 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 and 1 column is missing. Now in this case, okay, since you have 10 columns and only 1 column is missing, if I drop this column, okay, I decide, okay, let me drop all the missing columns. So you are losing important data as well. Just because 1 data is missing, you are losing 9 more data, which is probably not a good thing. But let's say out of 9, 6 data are missing here. In this row, 6 data are missing. Then if you drop also, you're not losing much, right? So in that case, it's better to drop those rows. Similarly, in columns, if 90% columns are blank, you can drop the column itself. Okay, if 70% data, it's not that rule that it should be 90 or 70, but it's up to you. Okay, but what I'm trying to say is, if the row or the column has more data missing than the data that they have, it's better to drop them. Okay? So you simply delete them. Okay, fine, that's easy. But when you have some case like this, where let's say you have other values, but only 1 value is missing, just because 1 value is missing, dropping is not good, right? Because you are losing more data. So in such case, what we do here, okay, in machine learning algorithm, is we find the average value, and then okay, so to replace this, we'll find the average of the four values and we'll replace here. Okay, now why take only average? in machine learning, okay, if the values are average, okay, it does not have much impact on the analysis. So we don't want this data to have any name because we don't know what it is. Okay, if someone tells you it should be a high value, then fine, you can take something like instead of 72, probably you can add 70 or 68. You can do that. If somebody says it's a low value, probably we can add 45, 48, 50. But we don't know what it is, right? So instead of putting some value, okay, we want blank will not be handled in mathematics, right? Mathematics means numbers. It has to have a number, right? So if you give an average number, then it's not going to have any impact on the analysis. Okay, it is not going to have impact on analysis. So we give average so that this particular cell will not have any impact, but at the same time we are retaining the other values. You got it what I'm saying? So that particular missing cell will not have any impact on the analysis, but other columns, okay, will be part of the analysis. Yes, no? Tell me if you don't understand. You guys there?
Yeah.
Did you understand what did I say here?
I did.
Mm-hmm.
I did.
Great. Okay, so we replace with mean because okay, we don't want that particular value to have any impact, but but the other values which are non-missing, they will have their own role to play. Okay, so first you see the count. Okay, if more rows are more rows or more points are missing, drop them. Okay, otherwise you replace with average value. Then categorical value. Now categorical value, mostly when you see it, it has to be handled different. So I'm talking about the feature, okay, not the output. Okay, I'm not talking about the Y value, I'm talking about the input feature. If there's a categorical value in the feature, okay, now you see categorical value will be some text value, right? Male, female, yes, no, right? Mathematics will accept only numbers, isn't it? So what we do first step, it requires two-step process. First step is we convert them into numbers. Okay, so let's say if it is region, in this case we have region, right? North, south, east, west, 4 regions. So we'll say, okay, we'll say east as 0. First comes E, right? So east is 0. Then you have north, so north will make it as 1, south as 2, and west as 4. No, 3, right? 0, 1, 2, 3. Fine, great. You have converted the text to numbers. But when you convert into numbers, okay, challenge is when you say 3, okay, west has 3, you just number them something, right? But when you enter the value into analysis, what mathematics will think, oh, west is 3 times more stronger than north. North is only 1, south is 3. So it is 3 times more importance. We'll start looking at the ratio, right? East is 0, right? That means east is absent, that is east will have no role to play. 0, no role to play. West will have 3 times more stronger than north, which is not true. All these values are equally important. Okay, so we say it is categorical. In R, it is much easier. You just indicate that it is factor. When you say it is factor, okay, algorithm will analyze. Oh, it's a factor. That means okay, I have to convert it to numbers. Not only convert it to numbers, but all these values are equally important. Okay, so what it does is, okay, let me do it in Excel and show you. So how do you make it more equally important, right? So let's say you have data, and let's say you have a region, okay, and you say east, west, north, south, west, east, south, east, north. Let's say this is the these are the regions that you have. Now what it does is it will convert this into one columns gets converted into number of row values that you have. It is only one column region, but when we say it is factor and we give it to machine learning, it will convert into east, north, south, and west. Okay, now east is here, so east will become 1, rest will be 0. Okay, east is 1, rest will be 0. Here west, so east is 0, north is 0, south is 0, west is 1. Okay, 0, 1, 0, 0. South, so 0, 0, 1, 0, 0, 0, 0, right? East, 1, 0, 0, 0. North, 0, 1, 0, 0. Now, see, this makes more sense, isn't it? It indicates that east is present and north, south, west is absent. Rather than saying region, east will say 0, 0, 3, 1, 2, 2, 0, 1. Okay, if you enter this value, it means that, this is 3 times more stronger than this and these two are absent, right? Which is not the right meaning. That's not how we want machine to think. We want machine to think like this, okay? In this row, east is present and these things are absent. So this is how we handle categorical values. We convert column into rows. Did you understand the problem with this? The problem with this, because this is text. Text cannot go as input to the equation, mathematical equations. You have to convert text into number. If you convert this text into this number, then there's a problem because these numbers will have more dominating role. 3 will have more dominating role than this. It means that west is more more important than east. But that's not true. All of these are equally important, right? So that's why we have to convert into multiple columns, okay? And then you represent as 1, 0. That means this is present, this is absent, which is true. When you say E means east is present and rest are absent, okay? So this will go to machine learning algorithm, not this, or not even this. Yes?
Yeah.
Okay, so that's called handling categorical data. Last topic we'll do, and we'll end the day here for today. Okay, the feature scaling. Let's do feature scaling. Now, feature scaling is another problem. Okay, so let's say you have one column called age, and another column, let's say age, and let's say salary. Now, age will be in 2 digits, right? Minimum and maximum will be in 2 digits only, right? So let's say minimum is 18 and maximum is, let's say 78 or whatever, right? But salary, the minimum itself will be in, let's say 5, 6 digits. Maximum can get into 7, 8, 9 digits, right? Now, when we pass this value, okay, so see, in categorical, column itself is problem. So we converted into multiple columns. But here, if you see, column is fine, right? As a column, this is also fine. But when you pass these 2 columns, okay, talking about more than 2 columns, what machine will think? Oh, salary is 7 digit bigger, 7 digit, and age is just 2 digit. That means salary will have more say in your final outcome of output variable, which is again not true. Okay, yes, when you see 32 and 18, yes, this has to be twice as important as this. Okay, or when you see this problem, this has to be 5 times more important than this. Fine, but when you look at 2 columns, right, it is really not that way. So feature scaling, what it does is it converts the values. There are 2 ways to do it. One way is min max, where you convert values between 0 and 1. Okay, And second is we convert into between -1 to 1. Okay, doesn't matter. Okay, so okay, so there are two ways you can Z square way and min max. Okay, so here what will happen is, let's say so your minimum value will be 0, maximum value will be 1. Okay, and everything else will be in that proportion. Okay, so this will be maybe 0.3, this will be maybe 0.28, something like that. Here also you convert those. Okay, this will be 0, this will be 1, this may be 0.5, this could be 0.8. So within the same column, the relationship is maintained. Okay, but now if you look at across two columns, the values looks in similar range. So you want both the columns to have equal impact, but the data inside the same column, it has to differ because they are different, so it has to differ. So when you convert into min max, okay, so value with the same column, it maintains the same relationship, but across the column, it actually looks very similar in nature. Yes, did you get that? This is called feature scaling. So we did missing values, how to handle missing values. Then we did categorical value. You know what is the problem with categorical values, right? Why do we have to handle it? Then feature scaling. Feature scaling is also important because values may, if they're same range, let's say talking about, we have an example where you have R&D spend, marketing spend, okay, admin spend, let's say, and they're all in similar range, right? If they're 4-digit or 5-digit, okay, that means the same range. You can have 4-digit and 6 digits, right? Here, salary and age, there's a lot of difference. Here, there's spend, right? So then same range. If they're in the same range, then you don't have to do feature scaling. Okay, if everything is 2-digit, if everything is in 3-digit, everything is in 4-digit, okay, you don't have to do anything. But if there's a lot of difference, variation, you have to do feature scaling. Okay. So these three are the steps, minimum steps that you have to perform as part of pre-processing. Once we do this, then we perform what is called as training set and test set. Test set. Okay, what is training set and test set? Okay, your data will be given to you. Okay, and we know that, okay, it is regression. In regression, you'll have 100 algorithms. Okay, you pick one. Now, how do we know which algorithm is better? Before that, how do we know, okay, that we are doing better with the data set or with the machine learning? So you will have, say, 1, 2, 3, 4, 5, 6, 7, 8. Let's say your data has 10 records, right? 10 records. So what we do is we will pass only 8 to the machine learning. So we call this as training set. Generally, training set will be 80 to 75%, right? So what we're saying is that machine, you are hiding this. You're not passing this to machine. Okay, you're hiding it from the algorithm. You're not passing it. So randomly, you will take any 80% of the data and you will pass it. Okay, this we call as test set. Okay, so you pass a training set, and algorithm will be run, and it starts predicting. Now, to know whether how well they have done, you will pass. Okay, so here you will have Y. Let's say. Okay, I'll give something else. So this is your feature 1. Feature 1. You have feature 2, feature 3, and this is your target variable. Right? So what we give, we say that, okay, machine, this is the input data, and this is the output data. Learn from this. So your machine is learn. It has found the pattern. right? It's like showing 2, 4, 6, okay, not showing the 8. So your data, you have learned the pattern in your mind. Now you say, okay, you have learned the pattern, so predict. So here you will only pass the feature. You will not pass the target. Okay, you say, okay, now that I know that you have learned, please predict this for me. So machine will predict some value, let's say 12 and 13 or 14. Okay, you have this value, you compare it, 13, 16. So these are original values and these are the predicted values. Okay, now you can compare how well your machine has done the prediction, isn't it? So we divide the data set into training set and test set, and this is done only in the supervised learning. In supervised learning data only, you will have target variable, isn't it? So you divide this into training set and test set, and you pass the training data, both feature and your features and your target, and you want them to learn based on that, and then test it. It is to test your machine, saying, okay, it's like this. Your teacher will teach you in the class. Okay, in the exam, they'll ask you different question, right? For which teacher knows the answer, but you don't know, they have not told you in the class. So you will give your answer, which is, this is your answer, and this is teacher's answer. So you'll say, okay, you are very close, so probably you're doing great. Okay, if you're very far, let's say if this is 130 and 160, and you're getting 12 and 14, then you know that this machine learning algorithm is not good in this case, right? Either we have done some mistake or algorithm is not good, right? So this is to test the model. That's why we call it test set. Test the model. Okay, model that you have built, then the algorithm that you have written, how well your algorithm has worked is can test it on the test data. So you provide a training data for it to learn, and then you say, okay, this is the input, and you hide the output. Okay, like I gave you, I've kind of hidden that last one, right? I gave 8 and hid the last one. You say 10. That's okay, 10, and then you see, oh, 10 is matched, 100%, right? So that's how we actually do. So these are the steps that will perform in all the supervised algorithm: missing value, handle, vector, the categorical value, okay, the feature scaling, and finally, we'll create the training set, and training set is given for the machine to learn, and then you will test it on the test set to know how well they perform. Yes?
Yeah.
Okay. So, so these are the pre-processing step. Okay. Before you run the model and do all these things, data has to be in this. Then you run the model, and then you have post-processing. Post-processing means you want to measure. Okay. So we measure how well the output has been predicted by the algorithm. So your performance analysis, performance of the model, right? Performance of your program. Okay. Performance analysis is done as post-processing. Okay, we will do it. So okay, so pre-processing is same whether you want to do supervised or unsupervised. Okay, regression, clustering, classification, data has to be in usual format. The post-performance varies for regression. All the algorithms under regression will have same performance way, but clustering will have different way to perform, okay, to analyze the performance. Okay, so we'll do it once we do the algorithm. Okay, we'll stop here for today. Any question before we end the day? Okay, and see, the next one is we will not do all of these. We'll do probably simple and multiple to tell you how it works. Okay, we'll talk about this in next session.
Okay.
Thank you.
Thank you. Have a good rest of the day. Take care. Bye.
Thank you.
Thank you.